right, ladies and gentlemen, here we are on a Friday. It seemed like the week flew by. We were off for 16 days. We had 4 days of school, and now we're going to have another 2 days off for the weekend. So it's a good life we live. We have 4 questions here from Chapter 8, just review questions. And if you want to try these, just press pause, try the questions, see if the answers are correct, and you can use this as a practice. Our first question I wrote twice because there are multiple ways to do it. Remember what we said before. Whatever you do to one side of an equation, if you do the same thing to the other, you will always maintain equality in your quest to isolate the variable. So in the first question, it's actually almost a grade 8 question, almost. If I added 3 to both sides, I know I get rid of the constant. And I'm with half of x is equal to, most of you could probably add a fifth to 3, right? Because it's going to be 3 and a fifth, pretty simple. And you're going to multiply both sides by 2. And if you think about 3 and a fifth times 2, most of you don't need to really do any kind of algorithm or work here. Because if you double 3 and a fifth, what would you have? 6 and 2 fifths, which is your answer, right? X would equal 6 and 2 fifths. If you didn't know that, you could theoretically change this to 16 fifths multiplied by 2 over 1, which is 32 over 5, which is 6 and 2 fifths. Okay? You could do it that way. But sometimes you just need to pause, use your brain, think about it. Doubling 3 and 1 fifth is pretty easy. The answer is 6 and 2 fifths. Now, with that said, that's not the only way to solve this question. I know in the room when I asked, what did you do? Did you add 3 or did you do something else? There were people that said, I decided to multiply both sides by 10. And the reason why they multiplied both sides by 10 was because they realized there was multiple fractions. Multiplying a fraction by a common multiple of its denominator will create a whole number. So they knew in doing so, they would create a new equation with no fractions. Since this is a binomial on the left, 10 multiplied by x over 2 will be 10x over 2, or 5x. 10 times negative 3 is negative 15. And 1/5 times 10 will be 10 over 5, or just 2. Once we get it down to this, we have a grade 7 question. Add 15 to both sides. And 5x will equal 17. Divide both sides by the coefficient. And guess what? X equals, uh-oh, I made a mistake somewhere. Where did I make my mistake? I made a mistake right here. 10 times, let's go back up here. 10 times negative 3 is negative 30. I'm going to add 30 to both sides. Oopsie daisy. 5x equals 32. Divide both sides by the coefficient of 5, and x will equal 6 and 2 fifths. The exact same answer that we had before. Just out of curiosity, how many of you did it this way? Show of hands. Most of you. How many did it this way? Good. If you really did it that second way, you're really starting to get the message about there are multiple ways to solve algebra questions. Fractions suck, generally speaking, because they're very time consuming and labor intensive. So if you can get rid of them by just multiplying by a common multiple of the denominators and create a new equation, generally speaking, it's an easier way to solve questions. Our second question just involves rational numbers in decimal form as coefficients and constants. Real simple. To get rid of the constant, we have to acknowledge that it's 0.2. Add its opposite to get rid of it. Half of x is equal to 0.95, if I'm right. $1.15 take away 20 cents would be 95 cents. Now look, watch this. I'm not going to grab a calculator for a second. I want you to consider this for a second. Would you agree we're dividing both sides by a half, right? Now if we think about fractions, what did we say when we studied fractions and we divide by half? What's the easiest way to solve that? If you divide by half, the easiest way to do it is multiply by the reciprocal, correct? What's the reciprocal of a half? Multiplying by 2, agreed? So dividing by a half is the same thing as multiplying by 2. So if I'm dividing by a half here, all I really have to do is double 95 cents, right? And doubling 90 cents is $1.80. Doubling 95 cents is $1.90. So therefore, x equals $1.90 or 1.9. Now if you grab your calculator just to double check, 95 cents divided by a half is 1.9. Make sense? Okay. Our next question, variables on both sides, 8.4. Padme, when we have variables on both sides, what is our strategy, generally speaking? Right, you got to get the variable off one side so you've isolated it onto one side of your equation. And the general rule we said is to get rid of the lowest amount because it has the most opportunity to keep your coefficient of your variable, in this case 3, the coefficient of your variable positive. Once you have that, it's a real simple equation. 3x equals 21. And x would equal 7 when you divide both sides by 3. And finally, your last question. We have, not only do we have variables on both sides, but we also have distributive property. So when you have this type of equation, Mito, what's the first thing you probably should do? Yeah, you should expand both sides using distributive property. Okay? So you need to expand this side because it's a monomial times y, and you need to expand this side using distributive property. So your new equation would be 3x minus 3.75 equals negative 2.5x plus 10, right? If I expand using distributive property. And once we do that, Will, what would you do next? I would add 2.5x to both sides as well. Could you subtract 3x from both sides? Yes, you could. Could you add 3.75 to both sides? Yes, you could. Could you subtract 10 from both? Yeah, you could add a donkey to both sides. It's still fine. But in doing so, we've gotten rid of the variable off both sides and kept it on one side, which is important because our goal is to isolate that variable. 5.5x minus 3.75 equals 10. 5.5x equals 13.75. And therefore, when I divide both sides by 5.5, x will equal 13.75 divided by 5.5 equals 2.5.